5D on the 2025 AP Calculus exam requires U substitution. Let's check it out. Part D says particle J is at position x equals 7 at time t equals 0. Find the position of particle J at time t equals 2. Show the work that leads to your answer. I like to call this problem a start plus accumulation. They give us the position of particle J at 0 and they say that it's 7. However, what they want is they want the position of the particle at 2. So I'm going to use the given position at 0, and in order to find the new position, I'm going to integrate velocity from 0 to 2. So let's go ahead and plug in our function. We get 7 plus the integral from 0 to 2 of our function, which is 2t times t squared minus 1 to the power of 3 dt. Now this integrand here is not a straightforward antiderivative, so we're going to have to utilize U substitution. I'm going to sub out the expression in the parentheses, and the reason for this is that I notice the derivative of this is 2t dt. And this expression I already have accounted for in my integrand here. So let's go ahead and make this substitution. What we get is 7 plus the derivative, or the integral, not derivative, from, we get u to the power of 3 du. And you'll notice I left off my limits of integration. The reason for this is our current limits are in terms of t. So if t is equal to 0, what this means is that u is going to be equal to u squared minus 1, negative 1. So my new lower bound is going to be negative 1, and my upper bound, if t is equal to 2, if we go ahead and plug this in, 2 squared minus 1 gives us 3. U equals 3. So these are my new limits of integration in terms of u. You could leave them in terms of t, and then you just have to substitute back in at the end, but I think this is kind of easier. Let's go ahead and bring it home. We have 7 plus the antiderivative of u to the power of 3 is going to be u to the power of 4 divided by 4, and we need to evaluate from negative 1 to 3. Thus, final answer here, we get 7 plus, we have 3 to the power of 4 over 4 minus negative 1 to the power of 4 over 4. Make sure you put parentheses around that negative 1. Very, very important, because negative 1 in parentheses to the power of 4 is different from negative 1 to the power of 4. There you have it. Did you get it?